In this lecture, we're going to pick up the concepts of solution stoichiometry from sections 5.5 and 5.9 that we weren't quite ready for the first time through the material. In section 5.5, we'll review the idea of using molarity to solve problems. Reactants and products may be given as molarities, as we've added to our diagram here and here. Molarity multiplied by volume can be used to calculate the number of moles of a reactant. Note that a chemical reaction will be described when this is a true stoichiometry problem, meaning that the dilution formula, M1V1 equals M2V2, is not appropriate. Let's look at an example. Find the volume in milliliters of 1.5 molar hydrochloric acid needed to react with 34.6 milliliters of a 2.44 molar sodium hydroxide solution. Note that we're given a balanced chemical equation, so to solve for the correct answer, we need to find the number of moles of sodium hydroxide present, then calculate the number of moles of hydrochloric acid needed. Once we know the moles of hydrochloric acid, we must calculate the volume of hydrochloric solution needed to deliver that many moles, then convert the number to milliliters. In section 5.9, we'll use molarity to solve titration problems. For example, we're asked to calculate the concentration of a hydrochloric acid solution when 25 milliliters of that solution is titrated to the endpoint with 2 molar sodium hydroxide. To do this, we first need to find the volume of sodium hydroxide solution used. In this case, 39.42 milliliters minus 2.17 milliliters equals 37.25 milliliters. Writing a balanced chemical equation, we see that sodium hydroxide and hydrochloric acid react in a 1-to-1 ratio, so we can use the volume of sodium hydroxide to calculate the moles of hydrochloric acid, then divide by that volume expressed in liters. We can also use titrations to calculate the molar mass of a monoprotic acid. First, we find the moles of sodium hydroxide used. A monoprotic acid will require 1 mole of base for every mole of acid for the reaction to go to completion. Taking the mass provided in the question and dividing it by the moles of acid, we get a molar mass of 189.5 grams per mole. As always, I'll leave you with the parting thoughts of the authors.